OSPF passive interface in NixOS. In this video, I'm going to talk about the passive interface configuration in NixOS. The concept of the passive interface is explained in the iOS part of OSPF course, but here first I'm going to review the concept of passive interface, and after that we will talk about the passive interface configuration in NixOS. The concept and also configuration of passive interface of OSPF is so similar with the concept and configuration of passive interface of OSPF in iOS. Let me to explain first the passive interface concept. Look at this scenario. As you can see, we have two switches, the switch 1, switch 2, NixOS 1, NixOS 2, and we can configure the OSPF between these two switches. For example, in switch 1, we can configure one interface as the interface VLAN 1. This is the interface VLAN 1. And after that, in the switch 2, we can configure interface VLAN 1 again. And we can configure OSPF between these two interface VLAN 1. And after configuration, we will have OSPF neighborship between these two switches over the interface VLAN 1. This is the, for example, first part of the configuration of OSPF. But in some cases, we have another interface VLAN. For example, in switch 2, we have interface VLAN 2, okay? And also in switch 1, we have interface VLAN 2, and also in switch 2, we have interface VLAN 2, or maybe some other interface VLANs, okay? This is not good, and in most cases, this is not suitable for our scenario to, for example, configuring OSPF between these two interface VLAN again, because we will have another OSPF neighborship. Assume that, for example, we have 10 interface VLAN in both switches, and we configure over all of them OSPF. And after configuring OSPF, because we need to advertise the address of the interface VLAN, we will have 10 OSPF neighborship. 10 OSPF updates should be exchanged, and we should use CPU usage, CPU of the CPU switch 1 and switch 2 for maintaining this 10 neighborship. Because of that, it's not good that we have for example, configure we have more than one neighborship between these two switches. We can configure other interface VLANs, okay, with the OSPF, and also we can configure that interface VLANs with passive as a passive interface. You know that if you configure one interface, for example, if you have a router and you configure one interface as the passive, on that interface, the router does not accept the, for example, hello message and OSPF hello, and also does not send OSPF hello. And this means that on this interface, we don't have the neighborship. We won't have the neighborship, OSPF neighborship, and it's good for example, some scenarios, or maybe other case of usage of the passive interface is on the LAN interfaces. Assume that in a router we have one interface connected to the other router 1 connected to router 2, and also we have one LAN interface in router 1 and also in router 2. You know that we don't need to establish neighborship of OSPF we don't need to send OSPF hello on the LAN interfaces, because here we don't have another router. Because of that, it's good to omitting the sending of the, for example, OSPF hello. Why? Because of the lower bandwidth usage, because the lower of the for example, CPU usage, and because to maintain the high security level in OSPF. Because of that, it's good to configure this interface as passive interface, and also the R2's interface as passive interface. We can use the passive interface feature for stopping the sending of the hello, and also to removing the acceptance of the hello on that interface. It is a good feature. In many scenarios, we can use the OSPF passive interface. The concept is same as the concept in the iOS, and also the configuration also is the same. You can configure every interface that you want as passive. For example, with this command, you should go on the interface and then using the IP OSPF, for example, passive interface. If you need, you can configure this command, IP OSPF passive interface, on the interface that you need to configure that interface as passive. This is the first method. This method is unique for NixOS. We can't use this command in the iOS, but also we have another method. In iOS also we have this method, router config router. In the OSPF mode, you can configure the passive interface default command. Passive interface default means please change the default mode of all of the interfaces to passive. Now all interfaces are passive, and after that we should change the interfaces mode in the interfaces that we don't want. We don't need to configure that interface as passive to non-passive. Look at here with this command, no IP OSPF, or for example, no IP OSPF passive interfaces. Let me to show you how we can configure these two methods. This is the first method and this is the second method. Let me to show you how we can configure this scenario. In this scenario, we have two switches, the switch 1 and also the switch 2. We can configure these two switches with the interface VLANs and also with the routed interface. I'm going to show you the configuration of passive interface on the, for example, routed interface. Let me starting with the NixOS 1. Okay, I'm going to first write the configuration here, and after that we can configure in the CLI command line interface. Okay, starting from the NixOS1, the switch 1. Okay, we can start the configuration with these commands. En, we don't need en, we should use the conft. Then we have one interface ETH21. Also, if you want, you can configure the host name as the switch 1. We have interface ETH21. First we should convert this interface from the switch port to the no switch port and routed port, and then we should assign the IP address. IP address for this interface is 10.1.1/24. We should enable this interface, and also we have another interface ETH22. Okay, then we should enable this interface to the routed port, no switch port. The IP address of the ETH22 is 10.1.1/24, and also we should enable this interface, no shutdown. This is the configuration of the NixOS 1, and after that we should this is the first step. We should configure the NixOS 2 also. This is the configuration of the NixOS 2. The host name is switch 2. We have two interfaces, ETH21 and also ETH22. Both of these interface are no switch port, and also the IP address of the ETH21 is 10.1.2.2. The IP address of the ETH22 is 10.2.0.2. Okay, this is the first steps. Let me configure this first step, copy and then pasting in the NixOS 1. Okay, very good. And after that, in the NixOS 2, copy and pasting on the NixOS 2. First, we should check the configuration until now. In switch 1, I'm using the show IP interface brief. Yes, we have two interfaces, and both of these interfaces are up. The ETH21 has 10.1.1/24 IP address, and the Ethernet 2.2 has 10.1.0.1. Both of these interfaces are up. Let's go to the ETH to NixOS 2, the switch 2. Show IP interface brief can show us that we have two interfaces, ETH21, ETH22, and both of these interfaces are up. And also, if you want, you can check the connectivity between switch 1 and switch 2. Ping 10.1.2.2, the IP address of the ETH21 of the switch 2. Very good, we have connectivity. Now we should enable the OSPF neighborship between these two switches. This is the second steps. The first things that you should first enable is the license in the Titanium NixOS. Okay, you should enable the license to have the right to configure the feature OSPF. The command, for example, in switch 1 is license grace period. After that, you can enable the feature OSPF. Okay, and now we can enable the OSPF router, OSPF 1. Then the router ID is quad 1. okay, in the switch 1.